actually looking at finding a relative maxima and minima, right? So basically we're looking at extremas and we need to know where is our max and our min, right? So definitely there's a process to this and we're just going to execute. So basically what it is that we're about. Let us say, for instance, we're looking at a curve like this, okay? And when we're referring to our relative maxima or minima, how we could find that is we're looking at these places where the slope is equal to zero. We are actually looking for those. In order to achieve that, we are going to actually find the derivative, all right, of the given function. And then we're going to equate that to zero so that we could actually find the values of x at these places here. And from there, we could now test to see what's going on. We're going to test to the left to see if we're getting a decrease or an increase, stuff like that. We're looking for those. We're looking for those increase or decrease. So the bottom line is, if I'm at a minimum, like right here, I'm supposed to have a decrease and then increase because my critical value would be right here. And for the maximum, I'm supposed to have an increase then a decrease because this would have been my critical value. But let us take a look to see what's going on. So we're going to just leave this here as reference. We're looking for that. So that's my critical going up. This is my critical. I'm going up and going down. We're looking for that sort of thing. So first, let's do the steps. First step is to take the derivative of this function. So we're going to do y prime. This is the first derivative. Basically, it's going to be 3 times, this is a 1, negative 1, so 3 times negative 1. So this is negative 3x raised to the second, and then 2 times negative 3 is negative 6, and then x, take 1 from that, is just x to the 1, which is just basically x. The derivative of a constant is 0. So this is what we actually have. So basically, so this is our gradient, or what we call our slope function. We're going to let this equal to 0. So negative 3x squared minus 6x, we're going to let this equal to 0. And then we're going to solve to get our critical value. So let us factorize quickly. Let us say we factor out the negative 3x, okay? So we factor out negative 3x, open our bracket, we're going to actually have x plus 2, right? So we're going to have x plus 2 here, and this is equal to 0, right? So x plus 2, and that is actually equal to 0 right there. So in doing so, basically, it's either negative 3x is a 0, which means if we divide throughout by negative 3, we found one of our critical values here at 0, or it's going to be where x plus 2 is equal to 0, and in that said, x is equal to negative 2. And this is our second critical value. So having known our critical values, we can now use the number line to test. For example, let's drop our number line here, just a quick test. Now, negative 2 may be here. We probably have 0 here. So what we're testing, we're going to be testing in these regions, values from these regions to see what's going on. Because remember, these are our critical values right here, right? Now, a number to the left of negative 2 could be negative 3. And then I could use, right here, I could just use negative 1. And I could use 1 here. So I'm going to use those numbers right there, right, to test values of x, because we want to see what's going on to the left and to the right of our critical values. All right. So let's start off. All right, let's see. Remember, though, that if we get a negative number, then that means we actually have a decrease, right? So our slope would have been a decreasing one. All right. And then if we have, so this is when we get a negative value. And if we get a positive value, when we test, slope function, then we gotta increase, all right? So we're looking out for those as key. All right, now let's test with -3. And I'm gonna be testing in the derivative function, not the original one. So I'm gonna just test it quickly in this right here. So let's write it right. So we have -3x, and then we have x plus 2. We're trying to see if we got positive or negative number. So -3. So if I substitute -3 here, all right, let's take a look. This will give me a positive 9. And in here will give me a -1. So already you're seeing that when we multiply these, it's going to be a negative number. That means we're actually having to the left of -2, we're coming down like that. So it's a decrease, right? So that's what we have there. So now we're going to test -1. So it's going to be -3 times -1, open bracket, -1 plus 2. Negative times negative here will give a positive, and -1 plus 2, this is also a positive. So when you multiply two positive, you will get a positive. So basically, we don't really need the value. We just want to know if it is negative or positive. So this is going to be increasing right here, like that. Now, let's test at +1. Let's go for +1 right here. So -3 times +1, and then 1 plus the 2. -3 times the +1 will give a negative number. +2, +1 will give a positive number. Negative times positive is a negative. So at 1, we're going down like this. So what we're noticing now, we're seeing the flow. We could see. So if we take a look, basically we're seeing where we're going down like this, coming up, coming down. We're seeing that sort of idea. So now this is giving us a good clue of what's going on here and what's going on here at 0. Now we could see that at -2. So let's put it right here. When x is equal to -2, you could see right here, this is a minimum. We are at a minimum right here. All right. And when x is equal to 0, so when x is equal to 0, this is where our maximum is, our maxima. That's where we are. So we could see that. Now, if we want to get the coordinates, right, all we're going to do now is to take these values of x and go back in the original function if we want the coordinates, like what is the coordinate for that point, right? So we're going to just drop that to get the coordinates of the point. So let's write back y is equal to -x⁻³ minus 3x squared minus 1. So I'm going to do it when x is equal to 0, all right? So y is equal to negative, then 0³ minus 3, 0 squared minus 1. So we're definitely seeing that this is going to land us -1, right? So at 0, when x is 0, we have -1. That's the point. That's the point right here. And remember, at 0, this is at our maximum. So our maximum point is 0, -1. Let us check to see our minimum. What is it? So again, y is equal to, now we're checking that x is equal to -2. All right. So all we're going to do is substitute. So negative. So we're going to put -2³ minus 3, and then -2 squared. And we take 1 from that. So this is going to give us -8 with another negative. This is now positive. This is +4. This is now -12. Then a -1. All right. So basically, this is 8 with a -13. This is going to give me a -5. So y is -5. But what is my coordinate there? It's going to be with -2, -5, right? So this is where my minimum actually is, my minimum, right? So basically, that's what we have right there. Now, see you next time when we were looking at another video. And